Hi, welcome to my second pedagogical transformation. Let's go ahead and get started. Today we're going to be talking about distance versus displacement. We'll also be talking about speed versus velocity, and we're going to be talking about these two in order to start to define what a vector is. Let's go ahead and start off with distance versus displacement. As you can see on the right side of the screen here, there's a little diagram that's kind of illustrating the differences between distance and displacement. Distance is all about the path taken. If you look at this and think of maybe, say, a runner, say somebody who's running cross country. The distance that a cross country runner runs in an event is usually 5 kilometers. So if we're looking at this, all of this path that they go, no matter if it's up or down, right or left, it all accumulates in an additive way to 5 kilometers. But displacement is just the distance, is just the change in position from their starting point to their ending point. So with that said, let's get in our partner groups, and we're going to use this diagram in order to define the differences between distance and displacement. We're going to have the right side of the room over here to use this model in order to define distance, and we're going to have the left side of the room over here use the model to determine what displacement is. So we'll give you a couple minutes, let's say 2 minutes, and we will get back together and see what you got. Okay, thanks for doing that. Now let's go ahead and have Harrison and Lissa's group come up and define what they got for distance. Okay, good. Are there any other examples of distance and displacement? Distance that you guys can think of? Just anybody? Good. Yeah, that's very good. Exactly. So let's write all these down on the board. Distance is additive. It's an accumulation. Good. What are some examples? Yeah, going to the grocery store is a good example, because you go a lot of different routes to the grocery store, so you can have different distances. Very good. What are some non-examples? Yeah, there are a lot of non-examples. Displacement also could be distance. Yeah, very good. That's a good way to think of that. Okay, so let's think of displacement now. What's a good definition for displacement? Okay, good. Yeah, the distance or position changed. Very good. What are some examples of displacement? Yeah, the grocery store example works again. You could go a number of different paths to the grocery store, but the grocery store is only going to be a certain change in position from your house. A certain change in position from your house. So no matter which route you take, it's always going to be the same displacement. Very good. Okay, with defining distance versus displacement, let's look at this example. Alright, I'll go ahead and read it. Edgar eats more apples than humanly possible. When he finishes eating all the apples from tree A, as you can see where the bike is at, he feels fat and cannot ride his bike. He decides that he will walk to his house first to burn some calories before he goes to eat all the apples on tree C. So what is Edgar's distance traveled and his displacement? Harrison? Yeah, okay, good. He travels a total distance of 7 meters. Very good. while his displacement is only 5 meters. So I know this seems kind of boring at times, but it's important to talk about this so that we can understand what speed and velocity are, because these two kind of get confused a lot in our minds. It's kind of easy to think that they're interchangeable, and sometimes they are, but not all the time, and that's important to understand the differences between them. So when we think of speed, we think of it as referring to how fast an object is moving. Say for instance, if we are driving to Salt Lake from Logan, we say that that is probably a distance of 120 miles, give or take 10 or 15 miles, whatever. But let's say it's just roughly 120 miles from Logan to Salt Lake. And we do that in 2 hours. So are we saying the distance traveled or the displacement traveled? I think that we oftentimes are thinking distance. So if we travel around the road, we're going 120 miles. But we do that in 2 hours, and so we say we have a speed, an average speed, of 60 miles an hour. So it's good to decipher what average speed is and what instantaneous speed is. Because average speed is going to be taking 2 points and determining how fast you're going just over that amount of time. Whereas an instantaneous speed is an instant in time, 1 point in time, determining how fast you're going. So if we're driving from Logan to Salt Lake, there are times when you're definitely going to be going faster or slower than 60 miles an hour. So if you're one of those hot rods that likes to go 90 miles an hour around the interstate, after you get out of Brigham City, you might be going 90 miles an hour at one point. And that would be your instantaneous speed. That's the speed that you're traveling at one point. Velocity, however, is a bit different, because it refers to the rate an object changes its position. To think about this, we're going to look at an example using this little computer model. So if we look at this, there are several different components that need to be taken into account here. We'll run this once so that I can show you kind of what it does. I don't know if it'll work. Here we go. So as the boat moves, there are several different things going on. Okay, we have to take into account that the boat is moving towards the shore on the opposite side. So that's going to be one velocity, because it's just counting its displacement from one point to another, straight line trajectory. So the boat is moving from this point to this point on this vector line, or on this arrow, at a certain speed, at a certain velocity. Also, we need to think about the speed of the water, which is variable. We can change that up. Or the speed of the boat, which we can change that up. So the three different components that we have here are the boat to the shore, as shown by this vector. The boat to the water, as shown by the water speed, just traveling down. And the water to the shore. I think I got that wrong. The boat to the water is going to be the boat speed traveling in a straight line out this way. And the water to the shore is going to be traveling in this direction from left to right. Okay, so let's drag this back and show you just simply this. Okay, you can see that depending on the components of the water speed and the boat speed, the boat to shore vector or velocity is going to change. Okay, that's it for today. If we'd like to have you have any questions, feel free to ask them at this time. Thanks.